All right, we're starting Unit 2. Unit 2 starts out relatively easy, in my humble opinion. Starts out with a fancy word called extrema. Extrema is just another word for does this equation or function or graph have a maximum value or minimum value? And it starts out pretty simple. Maximum value is like a parabola. It goes up and down. It's like a golf ball or football, baseball. Goes up and comes down. So the maximum would be the high point. And then here you've got multiple peaks, but like a mountain, that's the maximum height. So we call that the maximum value. And if we actually had to talk about where is the max, we'd talk about the y value, because the y value is up and down. Minimum is just the opposite. Something goes down and comes up like a roller coaster. So this would be the minimum value, pretty simple. This has multiple low spots, but like the ocean, this would be the lowest spot. So the minimum there would be my y value of my coordinate, my ordered pair. A different concept they're going to hit us with for this whole trimester / year is the function increasing or decreasing? The key to answering this question is you have to just know that you're riding the roller coaster left to right. So pretty simple one, like y equals 2x plus 1. Y-intercept is 1. Slope is up 2, right 1. There it is. Well, if I'm on a little roller coaster for the whole thing here, and I'm moving left to right, my journey is going to be up. That's increasing. This is a little different. So if we put our little roller coaster cart right there, this would be decreasing from here to here, and then things would change immediately right at this point, and then it would begin increasing. So it's decreasing from this portion of the graph, it's increasing on this portion of the graph. Here we go, another type of graph. So just imagine our roller coaster without me drawing one, I'll just make a dot. We'd be going up, increasing. How about this one? Dot, decreasing. This one's a little bit tricky. Similar to these, but if my roller coaster is right here, or my roller coaster cart, I'd be going decreasing from here to here, increasing from here to here, and then decreasing from there to there. So pretty easy start. Okay, this concept should be a review for you. You've been introduced to it in pre-algebra, algebra, algebra 2. So it's something math just doesn't let go. So we're solving systems of equations. Now systems just means two or more. As you can see, we've got two equations here, two equations here. This is a linear equation, this is a linear equation. So really, there's three possibilities. Number one, two lines can intersect at one point. They can be parallel, and therefore they would have no solution. And this one is your 99% of the time sort of problem. This is your 0.5% of the time problem. And then there's one more where you have a line and then you have a different equation that's a line, and they end up being the same line. And that doesn't happen very often, but I'll throw it at you just so you're aware of it. So what are we trying to find? We're trying to find where these 2 points intersect. So substitution, as you can see, we got y equals 2x plus 6. And I'll talk about this in a minute, but y equals 2x plus 6. So we're just going to substitute 2x plus 6 into the other equation for where y pops up. So we get 2x plus 3 times 2x plus 6 equals 10. Just do your basic math skills. Distribute. 6x plus 18 equals 10. I'm going to subtract 18, subtract 18. So I get 8x equals negative 8. Divide by 8, divide by 8. X is negative 1. That's fortunate. These can sometimes turn into nasty little fractions. Don't panic if that happens. So I still need to find y. You might as well put this in the easiest place possible, which would be right here. So that's 2 times negative 1 plus 6, which would be 4. So my answer here would be negative 1 4. Now, I alluded to sometimes you get parallel lines, which is no solution. But the question is, how would you know that in your math? Well, in the process of solving for x and y, your x will just disappear, your y will disappear. You'll end up getting something like 7 equals 12. And the two variables that you're trying to find just disappear. So just be aware of that. That would be a no solution. If it's the same line, your variables will disappear, and then you'll end up getting a true sentence, and that's telling you it's the same line. I don't think that's going to happen in this unit, but be on the lookout for it. Now we've got elimination addition. Something you guys have to understand, I'm just making this up, 7 minus 2 is 5, 10 plus 6 is 16. If I add two true equations together, 17 plus 4 equals 21, I get another true equation. That's just telling you you can add equations at any time if it's to your advantage. Now, if I added these together right now, I'd get 7y minus 5x equals 3, and that didn't do me any good. Look at this, elimination. So we want to eliminate one of our variables. Notice I said one of them. Doesn't matter which one. So I'm going to look at this 4y and 3y, and I'm going to say I'm going to multiply this by 3, and I'm going to multiply this by negative 4. If you're wondering why, just take a good look here. I get 12y minus 9x equals 6. Negative 12y plus 8x equals negative 4. I'm going to add these together. So these eliminate. So I get negative 1x equals 2. So positive x equals negative 2. So now I can plug this in anywhere. So I get 3y minus 2x equals 1. 3y minus 2 times x equals 1. 3y plus 4 equals 1. Subtract 4 and I get negative 3. Divide by 3, I get negative 1. So negative 2, negative 1. That's how you use elimination / addition. All right, now they're introducing you another review concept, looking for like terms. So way back in the day, you had said, hey, those are 5x, and these are like terms, so minus 5y, and you'd say, I'm done, because you can't add not like terms. Over here, we got 2 square root of 2, 3 square root of 2, that's just 5 square root of 2. And then 2 square root of 3 minus 7 square root of 3 is negative 5 square root of 3, and that's all the farther you can go. Now we got to apply this concept to these. Now you're like, well, those aren't like terms. You're right, but remember, we break down these square roots like so. The biggest perfect square root, and then 75 is 25 and 3. Here we'd have 3 times 2, which is 6 square root of 5, and 4 times 5 is 20 square root of 3. And because these are not the same, you're done. One more concept. All right, last thing. So what we're going to do is we're going to remember our parent function, f of x equals x squared, looks like this. And then it's saying find the equation for this, which means take 4x, put it in for x, and see what happens. So we get f of 4x equals 4x squared, which is 16x squared. And if you think about it, what this is doing is every value for y in the original parent function is being multiplied by 16. So that would make it a lot skinnier, which skinnier means two things. That's called a vertical stretch by 16. The y's are going up by a factor of 16. And the other thing I want to talk about, and this is the grand finale, is what happened horizontally. Horizontally, it's getting shrunk. So I could say that's a horizontal shrink, and they do use the word compression, but now is where something gets interesting. If I take $100 and I cut it in half, that's 50. If I take $100 and I multiply it by a half, that's 50. I'm shrinking things, but notice this person would say shrunk by 2. This person would say shrunk by 1/2. So when you see the word shrink or compression, you could actually use both of these depending on the math you're thinking about. But in my case, it would be horizontal shrink by 16 or 1/16. Just understand, you can talk both of these talks as long as you know what you're doing mathematically. And that finishes your example problems. Good luck on your homework.